Welcome. In this video, I'm going to give an example of the design of an experiment. You can find the final report from this experiment online. Here's a URL, learningfordoing.com, example design of an experiment. And the purpose of this video is to share with you a few ideas on how to do great experiments. Here's a tip. If you want to find great examples of design of experiments, look in journals, because most research papers are great examples of how to do experiments. So for this example, I selected the Journal of Biomechanics. This is a top-tier journal, and I selected a study of bicycling, and this involves experimental study, i.e. wind tunnel, and computational work, which is CFD. And the term CFD stands for computational fluid dynamics, and this involves solving the equations of fluid mechanics using computer algorithms. So I have the research paper online, and if you start looking through this, boy, you notice a lot of black ink. So very, very detailed, but there's a really key idea. So the report of an experiment, especially when it's academic research, they're generally very detailed and complex, but the essence is simple. And so I took this paper and I wrote out kind of the key ideas, and I'll show you that next. Okay, at the start of the journal article, the researchers tell us that people want to understand how to reduce aerodynamic drag on a bicycle rider. And then they identify some really key issues. And these deal with how to model turbulence in the computational fluid dynamics. And they say the real purpose of this is to evaluate the use of computational fluid dynamics and look at some of the limitations of this CFD modeling. So what they've done at the very beginning of the article is simply said, of course we want to understand drag, and here's the key issues. In the methods section, the authors tell us we're going to do some experiments. So we're going to mount a bicycle in a wind tunnel and measure drag on the bicycle plus the rider, and here's what our apparatus looks like. And we're going to instrument a bicycle rider, as shown here, and measure pressure at like 30 locations. And we can compare this data then with the computational fluid dynamics. The authors describe their numerical methods, and they tell us we're going to use two techniques, the Reynolds average Navier-Stokes and large eddy simulation, and we're going to use both these techniques and then compare these numerical predictions with the wind tunnel data. So the methods themselves on the surface are really quite simple, and in the paper they give us all the critical detail, which is of course very important. My favorite part is the results section, and in this section the professionals tell us that the numerical results and the experimental results differ by about 11% and about 7% for the two numerical methods. And they state that this is close agreement. And they also tell us that they get fair agreement with the predicted surface pressures, and they suggest that RANS is the best numerical method to use. The authors conclude that the CFD is worthwhile for analyzing drag, and they give us this incredible table of all this data. And so I looked at this and I go, man, there's a ton of things in here I can use to better do fluid mechanics. So in the results section, they're giving us very useful information. So the essence of an experiment, they have a purpose. Understand drag on a cyclist so we can reduce it. Key issues. What's the best way to do the computational fluid dynamics or the numerical method? Methods for gathering data. We're going to use wind tunnel, measure drag. We're going to measure pressure at various locations. Methods for analyzing the data. We're going to compare the experimental data with numerical predictions and see how close they come and make some inferences about how to do numerical modeling. Then they present some very useful results. And one thing I haven't talked about yet is the literature review, in which they figure out or teach us existing knowledge. Let's go on to that section. The lit review, the authors, they figured out what is already known, and then they wrote this in a way that we could understand what they had learned. And the whole idea of the literature review is, why not take advantage of the collective wisdom of humankind? Why reinvent the wheel? Literature reviews are super important, and I want to next show you two examples of their literature review. In example one, they're teaching the basic ideas of aerodynamic drag. So they put out the standard drag equation. They define the variables frontal area A in units of meters squared. They tell us that often people use the drag area, which is the product of area and the coefficient of drag, instead of simply the coefficient of drag, because area itself, as they state here, is very difficult to measure. And so they're just laying out the main ideas. This is really superb. In example 2 from the literature review, they give us some very useful information. At high speeds, and they quantify this is about 50 kilometers per hour, which would be about 30 miles an hour. About 90% of the drag on the cyclist is aerodynamic drag. And they give citations so we can understand where these numbers come from. And then they give us some numbers. About 60% of the aerodynamic drag is due to the cyclist's body, as opposed to the bicycle itself. And I knew kind of some of these things qualitatively, but it's really good to see some numbers and see some citations. And then they go on to explain more about the nature of the drag in this later section. So you might check out how they did their literature review. This is a pretty good example of how to do a literature review when you're doing any experiment. So here's some summary ideas about the literature review. Your whole goal is to provide useful knowledge to your reader, and of course you learn a ton in the process. You want to give evidence, in particular citations, and you always want to explain things in super clear, simple ways. Okay, here's the actual organization of the paper. So I just cut and paste the section headings. They started with introduction, then they talked about aero drag, then they gave their methods, they gave their results and discussion, and then their conclusion. And let's contrast that with the standard way to write in science, which is called IMRAD. In IMRAD, you start with the introduction. You see it in this section, so both 1 and 2 are introduction. Then you give your methods, that's the M of IMRAD, and you see their method. Then you give your results and discussion, and you see right there results and discussion. And then you give your conclusions, the most important part, where you give the readers the results. But what you can see looking at this paper is it totally follows the IMRAD structure. And it's amazing how many good experiments you can look at and just see this structure almost line item in the section headings. And in your introduction, you want to kind of do 3 things. Make sure you tell your readers why you're doing your experiment. Identify the key issues you're addressing with your experiment, and summarize the existing knowledge, that is, do a literature review. So we can summarize how to do a great experiment. Find your purpose. Reduce drag on a cyclist. Identify key issues. In this case, what are the best CFD approaches? Figure out and teach the key knowledge. This is the literature review. And then apply valid methods for gathering data. In this case, they use wind tunnel and pressure measurements, and those are used in thousands of fluid mechanics research problems. They discuss, analyze, and interpret the data and tell the reader what this stuff really means. You can totally see this as you skim through the article. And then in the results section, they just laid out the results. It's very easy to figure out what they wanted us to get out of this. And as they wrote their paper, they just organized it with introduction. Here's our methods, here's our results and discussion, and then they presented all their results in the conclusion section. And if you look at their abstract, it does all these same things too. So writing an abstract is nothing more than doing the IMRAD approach in 1 paragraph. So as you look at a really well done experimental study, it looks very linear, like it was very easy to do. And of course, it's not linear at all, and it's quite challenging to do. And the whole key is to recognize there's some standard steps. Find my rationale, figure out the existing knowledge, guess my solution, plan out my experiment, execute my experiment. But what makes this really go is doing it over and over in iteration cycles. And this is really the key, and this is probably the most important thing I have to teach you in this video, is always do an experiment with iteration cycles. That concludes this video. I hope you have enjoyed this. We'll see you next time.